Hey guys, welcome back. So today we're working on this PoulanPRO 6600 watt generator. This machine comes to us from a local subscriber, Jay, who found it on Facebook Marketplace. It was a free machine, and according to the listing, only needed a new fuel line. So he picked it up, no questions asked, brought it home, and it was shortly after then he realized that the fuel line was not the main story here. The engine is locked up solid. He checked the oil and he said there was nothing in there. So even though this does have a low oil sensor, something happened to this machine. So he didn't pursue it any further. He offered it up to us and thought it would make a good video. So the goal today is going to be to, at a minimum, find out what happened to this engine. And the goal is going to be to get it up and running again. So let me get you set up a little bit better and get going on this. So let's just see how little oil there is. It should be filled up right up to the last thread. And I'm seeing a little bit on the bottom of that dipstick. Let's clean that off and check it. And although it would appear that it's low, it's definitely not empty because this has been sitting in the corner for a couple days and it actually left a puddle of oil. But yeah, nothing actually registers on the dipstick. So definitely not a good sign. It looks like the low oil switch, which is the yellow wire coming out of the engine, it is connected to the module. And the module appears to be connected to the rest of the machine. So it's interesting that, it would appear that a lack of oil caused this issue, but potentially it could be another. So let's pull the drain bolt and see how much oil is in that block. Yeah, not completely empty. And the oil that's coming out actually looks really good. So I'm inclined to think it didn't run out of oil because a lot of times when the oil gets super low, it ends up throwing the rod. And the oil usually looks pretty dark and charred. But this oil looks almost new. So definitely low, but not that low. This engine only holds a liter of oil. And I think we have at least half that was actually in the engine. All right, let's see how much we had in the engine. Should have been a liter, which is right up to there. And it looks like we're at about 600 milliliters. So yeah, definitely low, but the engine should not have blown with that much oil in it. So I would say we didn't run out of oil, unless someone ran this on a hill. So the other possibility is that the engine might be weather seized, meaning the cylinder has a bit of rust in it. Tank looks to be in good shape. No rust. The fuel doesn't smell bad, so that is a good sign. So let's get the spark plug out. Let's see if that sheds any light on the situation. Yeah, plug spinning out pretty easily. Just want to see if there's any rust on the tip or any sign that the piston hit the plug. Yeah, no red flags. The plug looks really good. There is no rust at all on it, and it hasn't been regapped by the piston hitting it. So Yeah, no red flags other than the fact that the engine doesn't rotate. So I'm going to get some penetrating oil down in the cylinder, and then I think we'll get the starter recoil off and see if the engine will rotate backwards. And we'll get a little bit of Marvel Mystery Oil in there as well. And the piston's actually pretty close to the top. So it doesn't rotate forward. Haha, it does rotate backwards though. But it does come to a very hard stop. It almost feels like a valve is trying to open, but it can't. Let's just turn it backwards, see how far we get. And we're stuck again. So yeah, it's right when the piston's at about the top. So maybe we'll get the borescope down the cylinder next and just see if there's any obvious obstruction. Otherwise, might just be a valve. All right, let's have a look. Hopefully we don't see a valve sitting on top of the piston. And no, things look pretty good, although on the right side of your screen, I'm not sure if those are scratches or oil. Otherwise, I do see crosshatch. Piston looks good, no damage to that. And yeah, I mean, overall, not terrible. So let me switch to the side camera. We'll take a look at the valves. All right, the valve right there looks to be closed. And let's see if we can locate the other. All right, so both valves are closed. So let's try to rotate the engine and see if we can get the valves to open. So I'm going to back the engine up. All right, so that valve right there opened up. Not sure if that's the intake or the exhaust. Let's pan over to the other valve. And that is currently closed. So let's rotate the engine again. And it's actually stuck right at the top. Can't get the camera in there. But that valve is closed. Let's rotate the engine the other way. All right, so that one is the one that was opening. Let's keep going backwards. Okay, and that valve did open. I do see some junk on it. And we just made it past top dead center. So the oil might have just freed up the engine. Let's see. Yeah. Engine's rotating. And let's check for compression. I'm just going to put my thumb over the spark plug hole. Yeah. we've got compression. So the engine does feel pretty smooth. So I think it'll definitely run. It felt like we had compression. So I'm going to get some oil back in the engine. I do want to rotate this with the drill at high speed, just splash the oil around. Try to loosen up the rings if they're stuck, and then we'll throw the compression tester on there, maybe the spark tester as well, and see where things are at. Nice. All right, so I'm going to get the recoil back on. The engine felt good when rotating it over. There were no tight spots. It was nice and smooth. So I'm not sure if it was a stuck valve or just, a little bit of debris potentially on the cylinder wall. But whatever it was, doesn't seem to be an issue now. And when rotating the engine over, I noticed the airbox was just kind of flapping around. So let's take a peek in here and make sure everything looks good. Yep, no issues there. Let's check the throttle plate. Not stuck. So you always want to check that. The resting position's wide open throttle. So if it's stuck and you go to start it, the engine's going to run away. All right, I've got the plug back in. We'll just get the spark tester in place. And I'm going to kill the lights. Pull the engine over. Keep an eye on the light. Okay, we've got spark. Let's check the compression. All right, I'm going to pull the engine over a couple times. This does have a decompression system, so 60 psi is about the best we're going to see. And we are low at about 40. So that could come up potentially once we run the engine, especially if it was a valve hanging up. But let's pull the valve cover and just check where the clearance is at. All right, so the intake's open. We can check the exhaust. Should be 6 thousandths, but it actually is tight. So a tight exhaust valve could definitely impact the compression release because that is the valve that gets bumped. Let's check 4. And a 4 does fit, so it's only just a little tight. 5 does not fit. So yeah, the exhaust does need to be adjusted. Let's rotate the engine till the exhaust opens up, and we'll see where the intake's at. And the intake should be 0.4 of an inch. Yeah, and the intake's actually perfect. So let's open up that exhaust just a bit, and we'll check the compression again. Okay, 6 fits in there perfectly now. So let's do another compression test. Yeah, and we went up still on the low side, about 50 psi, but usually 60 psi plus or minus about 10 is kind of in the normal range. So, the fact that the compression came up by adjusting the valve clearance tells me that it's likely the decompression system just letting out a little bit too much. So I think the engine will start. We have compression. We have spark. What are the odds we have fuel? So let's take a quick peek at the fuel that's in the bowl. The fuel valve on the tank is off, so there's a chance it was stored dry. Nope, there is fuel in there, but that bolt, it is spotless. There's no varnish, no rust. So despite how this carb looks on the outside, I'd say there's actually a decent chance that it could run the engine. So I'm going to bypass the tank. We'll fill the carb up with some fresh fuel, and we'll pull it over, see if it shows any signs of life. Okay, the carb accepted fuel. Looks like the needle shut the flow off because the bowl is full. So I'm going to secure this line a little better, then we'll try to start it. All right, so what do you think? I am cautiously optimistic. So we've got the ignition on. We do have the kilowatt and a light plugged in. Let's turn the choke on. And let's see what happens. Well, you can't ask for much more. The engine started first pull, sounded really great, and the carburetor ran it absolutely perfect, not to mention the generator's making power. So really, there's nothing wrong with this machine now that the engine rotates. So we still have the initial complaint by the person who gave this away that it needed a new fuel line. But I did fuel it using the existing line, and there were no leaks. So potentially the issue is with the valve, or maybe the seal between the valve and the tank. So I'm going to drain out what little fuel is in there, get some fresh fuel in, and just see if there are any issues with the tank, the valve, or the fuel line. And of course, there is the possibility, too, that there never was anything wrong with the fuel line. Potentially, they just wanted this machine gone since the engine was locked up. So there's not much fuel in there. I'm not sure any's going to come out. And actually, the valve was in the on position, so now it's off. And of course, we weren't getting anything out of the valve. So let's turn that back off. Let's add a little bit of fuel and see if we get flow from the tank. Yeah, and things seem to be working just fine. We've got good flow coming from the fuel tank, through the line, through the valve. So I don't see any issues with the tank, the fuel valve, or the fuel line. All right, so let's put this machine to the test. It is rated at 6,600 watts. So the question is, will this previously stuck engine power its rated load? You know, that we're about to find out. So let's get the engine started. You know, while it's warming up, we'll double check the output using the kilowatt to measure the frequency in the hertz. We'll see where the total harmonic distortion's at, and also take a look at the sine wave. We'll then put on about a half load of 3,000 watts. If everything checks out, we'll go for the max of 6,600 watts. All right, no issues at all getting the machine started. Started right up first pull. And the engine speed, it was a little slow, but now that it's warmed up, it actually came up to a pretty good level. We're now at 61.4 Hertz, which is good. So let's check out the THD. Without a load, we're at about 4.9%, and the sine wave, it is jagged, for sure. It looks a little bit like a sawtooth. So let's start with a half load. There's 2,000 watts, 3,000 watts. We're holding at about 59 Hertz. THD jumped quite a bit, 21.3, and the sine wave smoothed out, but it is a little distorted. So we'll give this a few minutes. If everything checks out, we'll go for the max, a 6,600 watts. All right, it's been a few minutes, no issues at all pulling 3,000 watts. So let's bring it up to 4,000, 5,000, 6,000. No issues. Let's swap that. So now we're back at 6, and we're at 6,500. So a little slow. I'd say about 56 and a half. 23.3 on the THD front. And the sine wave looks pretty much the same. So let's give this a few minutes, and then we'll shut things down. All right, it's been a few minutes pulling the max load. So 6,500 watts on the load bank, about 100 watts for that light, plus actually 200 watts for the cooling fan. So technically, we're overloading it, and it's doing it without issue. So let's take the load off, we'll let things cool down, and then we'll shut it down. Well, I think we got pretty lucky on this one. Going into it, I assumed the worst. Anytime you get an engine that doesn't rotate, you've got to wonder what catastrophe happened to it. Did it run out of oil? Did it throw a rod? And in this case, neither. I think the main culprit was just a bit of carbon in the cylinder, and it doesn't take much to prevent that piston from reaching top dead center. So as soon as we got that cleared, the engine rotated and built compression. And as we just proved out, the engine is not down on power. It performed absolutely flawlessly. So I hope this video helps someone. Thanks for watching. And I think we're going to do a little bit of bonus footage here since this week's video was so short. So what we're going to look at now is a Honda ES 6500. This machine was dropped off by a subscriber. He picked it up as a parts machine, so he didn't pay a whole lot for it. But what he wants to know is it really a parts machine? If it's not, can we get it to run and make power? And if it is, then what parts are good and what parts are bad? So yeah, ideally, this would not be a parts machine. I think brand new, these sold for about $6,000. It is liquid cooled and has an inline twin cylinder Honda engine that was actually designed and I believe also manufactured by the Honda motorcycle division. So definitely a nice machine and one worth saving. Anyway, the story he got from this when he bought it from the prior owner was that, it was running and then the stator started to smoke. So Yeah, potentially the stator's bad, maybe something else. So let's start there. And it looks like there are some parts already missing. The voltage regulator is one of them. Now that is a discontinued part. The cover is missing and some shrouds right here. So even if this ends up being a viable machine, making it whole again is going to be difficult. Anyway, from what I can see of the stator, I don't see any burn marks, don't see any broken lacing. So no obvious red flags, but yeah, let's test it with the multimeter and see what that has to say. And luckily the brushes weren't removed, so we can test the rotor through the brushes. I haven't looked up what the resistance should be on this rotor, but usually, at least on Honda clones, between 40 and 70 ohms, and I'd expect something similar on this. Now, since we're going through the brushes, the resistance likely will be higher, which is fine. I just want to see that we have something in the ballpark of 40 to 70 ohms. And yeah, that looks decent, 103 ohms on the rotor. And we'll check it to ground. No fault to ground, so the rotor seems to be good. We'll check the stator next. It looks like all the wires that connect to the stator are already disconnected. I'm going to disconnect this, which I believe is the feed from the bridge rectifier that runs up to the control panel. So now we are mostly isolated. We actually have a ground wire connected right there, and if that's bonded to neutral, we'd see it coming down back from the control panel, but it shouldn't affect the reading from the stator. But out of curiosity, let's see if this is a bonded machine. So we're checking from neutral of the control panel to a source of ground. And no, it appears to be floating, which is fine. And then here we have leg 1, leg 2, and in the middle is neutral. So let's check those. And for most stators, the resistance is quite a bit lower, usually 0.2 to 0.5 ohms. I have seen some all the way up to 2 ohms, which were on a good machine. So really anywhere in that range is what we want to see. So I'm going to test from neutral to one of the legs. And yeah, 0.22 ohms. That actually seems good. That's what I would expect. Let's check the other leg. And that one's lower, 0.19. So that is suspect for sure. And if we check between them, we should see roughly double. And yeah, we're not quite seeing that. So something does seem off. We're at 0.22 on leg 1 and 0.19 on leg 2. So I would expect to see 0.4 between them, but we don't. We see 0.31. So yeah, that is a red flag. Potentially the insulation has failed and something isn't flowing the way it should. So let's check from neutral to ground, which we should not get a reading if the insulation's intact. And yeah, unfortunately, we've got a pretty strong reading, 0.6, 0.5 between neutral and ground. And neutral is connected to both leg 1 and leg 2. So I don't know exactly which leg failed, only that for sure we do have a failure on the stator. And I guess to be extra sure, let's disconnect the bridge rectifier. That does have connections to an auxiliary winding. And although unlikely, potentially the ground is getting picked up from there. All right, so we are 100% isolated now. And if we still show a fault to ground, then yeah, stator's bad, 0.4 ohms. So that is unfortunate. This part, the stator, it's discontinued, can't buy it new. And I checked on the used market. It doesn't seem to be available there either. But out of curiosity, let's test the sense winding as well as the DPE, see if that failed as well. And we're going to use this meter to check the DPE and the sense because the milliohm meter, the tips won't fit in there. So there are two windings that are connected here, DPE and sense. DPE is the power supply to the AVR, which is not present. And usually that winding has two wires of the same color, either two blue or two yellow. In this case, we have all different wire colors. So we're just going to have to probe around and find it. And usually on a DPE, you see about 1.5 to 2 ohms. And actually right there, we have a very low value. So I'm betting that is the sense. And if I probe over here, we can confirm that because it's connected over to the main winding. So that is likely the sense, the two connections here on the left. Otherwise, it could be another insulation failure. Let's check the other two, which should be the DPE, around 1.5 to 2.5 ohms. And yeah, 1.4 seems good. Let's check that to ground. And no ground fault. So it would appear the DPE winding is good. So technically, if we had an AVR, we could plug it in, and this would power up. But given that we have a fault to ground, that would heat the stator up and definitely let the magic smoke out. So yeah, unfortunately, the stator is bad, and it needs a new or used good stator, which I can't find. The new ones, they are long discontinued, and there is nothing currently on the used market. So if the owner, the subscriber, wanted to fix this, there's really only two options. Either find another parts machine with the parts needed, or he could send the stator out and have it rewound. This machine might be worth that. There is a place that'll rewind the stator for $850, but once you factor in tax and shipping, it's closer to $1,000. And this could get expensive fast because that's not the only expense needed to make this complete. We are missing the voltage regulator, the end cover, some tins. There's various parts already stolen off this machine. So in the end, likely it would take about $1,500 to $2,000 to make this thing work. And you could get a good one that does work for about $1,000. So yeah, this I would say is a parts machine unless a donor is located or potentially someone watching has a donor and willing to sell some of those parts. So we know the generator is bad. How about the engine? So let's turn our focus there. We'll do some basic checks, see if we can get the engine fired up, make sure it's good. And I would say it's very unlikely that we have engine problems. Obviously it was running, at least when the stator went up in smoke, but I think that was some time ago. And judging by the smell coming from the tank, it was at least, I would say, 4 or 5 years ago, because it smells definitely bad. I guess what gives me hope is that the cap isn't rusted out. So hopefully the tank is still good. So let me set you down, get the filter out, take a better look in that tank. I love Hondas, but these filters, kind of a pain. And yeah, there is some fuel in there. It looks like it might be starting to rust the tank up or varnish a bit. So the tank, it is still good, but if the fuel stays in there much longer, then this is also going to need a new tank. So a bunch of stuff in the way. The fuel valve is right there. And I'm thinking it's probably easiest to just pull this line right off the carb or run that down into a bottle and drain out what's left in that tank. All right, and nothing's coming out. So either it's clogged or, the tank level is just such that, the fuel pickup is above it. So yeah, I think we're gonna have to siphon out what's left in that tank. And you can see we got the majority of it out, and the tank actually isn't rusted. So this tank, at a minimum, is a good part now to use on something else, if not with this machine in the future, if it ever gets repaired. And let's check the oil next. Should be filled up right to the threads. And yeah, filled up perfectly. Well used, we might change that. But let's get the engine running first. Let's check the coolant. The overflow tank is pretty much empty. And I'm not seeing anything in here either. And no, it's not empty, but it is a little bit low. So let's top that off. We also need to add a little bit here to the reservoir. It's pretty much right at the bottom. The max line is up there. I assume that's the hot level. Well, it doesn't really say hot or cold. It says min or max. So let's aim for the middle. And there's actually a little note on the top here that a cold engine should be filled up so that the reserve is at the max. Close enough. And it's been sitting long enough to have a pretty big mud dauber nest built on the valve cover. So hopefully no one's home. I'm thinking we should get that removed before going any further. And this model, it is electric start only. There is no pull start. So we're going to have to add a battery to turn the engine over. I'm thinking before we do that, let's just pull the air filter cover. I want to make sure that is clear. And I also want to pull the plugs, get some oil into the cylinders. Yeah, it's pretty clean in here. And I don't see any mouse nest or debris in that filter, so that should be fine to test with. right, there's one plug. A lot of carbon, but no rust, which is a good sign. So likely water hasn't caused any issues with the top end, at least on that side. And same story on this one. A lot of carbon, no rust. So likely the engine is not stuck. And we'll get a little bit of oil down in those holes. So that was some penetrating oil, and we're also going to add some Marvel mystery oil. And for now, we're going to leave the plugs out. And I want to turn the engine over first. And did I mention this is electric start only? We don't have the key. So luckily Hondas, they pretty much always use the same key. And I actually have one on my generator I could probably use. But I also have some Honda clone electric start kits. And I believe this one has a key. Yeah, right in the bottom there. So let's see if that fits. And yes, it does. So it's telling us we have no oil pressure, which we don't because the engine's not turning over. So I'm just going to cover up this right here because it's going to shoot oil out when I crank the engine. And once we get that covered up, we'll crank the engine, make sure it rotates well, and that the system builds pressure. So just kind of drape that over the spark plug holes. Yeah, engine sounds really good turning over, but the oil light didn't go out, so let's keep turning it over. There we go. So we built enough pressure to shut that light off. All right, good. Let's check for spark. So all the spark testers I have are not compatible with this type of tip. So we're just going to put the plugs back in, dim the lights, and we'll crank the engine over, see if we have spark. All right, so let's check the plug on the right first. Yeah, nice strong spark on that plug. Let's check the left one. Yeah, we have good spark on both cylinders. So I'm going to clean these plugs up just a bit. You know, I don't think I have a replacement for them on hand. Let's see, it's a BPR 6HS. Yeah, I don't have a new one of those, at least not with the right tip. So we're going to have to run with that. All right, so let's check the compression here, starting with the cylinder in the front. Now this engine, I don't think has a decompression system, so likely we're going to see, well, hopefully somewhere around 185 if the engine's healthy. And yeah, that is pretty healthy. We have 190 on the front. So that is excellent. Let's check the back cylinder. And we're hoping for about the same, you know, plus or minus 5 or 10% is acceptable. The closer they match, though, the smoother the engine's going to run. And yeah, this one's down a little bit compared to the other. This one's actually, I would say, 185, but well within tolerance. So the engine should run, I think, quite well. That is assuming we have fuel, which likely we don't, given the smell from that tank. So let's get the carb cleaned up real quick and then try to start it. And I guess while we're here, let's get the plugs back in. All right, so this carb, it doesn't look too hard to get off. It actually looks very similar to a carb that you'd see on a GX 390. Although this engine isn't a 390, it's actually a GX series engine, but it's a GX 360. And you can't actually get a socket on this side because of the boot running up to the airbox. And it looks like that boot's actually clamped on. So I think the first move here would be to loosen that boot, get it out of the way. This panel here on the side, missing most its fasteners. It would actually be pretty convenient to have it out of the way, but there is still something holding it in place. And that's a lot better. So now we have easy access to this clamp. And the boot's actually ripped pretty severely on the back side. So yeah, that's not a good thing. So dirt easily could have bypassed the filter. So just something to keep in mind if this engine's ever used on something else, or if we end up fixing this machine. You know, it's just another part we need to make this thing complete. And we also have to remove the remote choke cable. And we can set that aside. And actually, I guess while we have it off, I can show you better the tear in the boot. So yeah, that wasn't doing much. And we've had two lines going down here. One is just the bowl drain, and the other one is the overflow. So thinking, let's actually drain the bowl. See what comes out of there. Yeah, there was fuel left in the carburetor. And it smells just like the fuel that was in the tank, but no water, so that is a good sign. And on this carb, it's a little bit tricky to get it off the machine. The way they have the governor rod connected to it, you can't actually slide the carb off the studs and then get it off the rod. You actually have to remove the governor arm to get the rod off, to get the carb off. So not a big deal, but usually, touching the governor arm is not a good idea. But in this case, Honda made it pretty easy to do with a couple fasteners right in the middle of the arm right here. So you don't actually have to touch the one that goes onto the governor shaft, which leads into the engine. So I'm actually going to get this breather out of the way. It's just kind of blocking view and easy access to what we're doing here. Actually, I may have misspoke here. There is a bolt right in the middle of the arm, but I think that's just for like resetting or calibrating the governor. You know, down here it's actually keyed, so it can only go on one way, and then if you need to reset the governor, you would do it here. So yeah, we have no choice but to loosen up this nut and pull the arm off the governor shaft. Yeah, it's moving. Slowly. Okay, and we're off. So I'm going to get the governor spring off if I can. And now the arm is free. All right, we're free. It looks like it's taking the insulator with it, which I didn't really want to do. It's got a vacuum line connected to it, so we need to pull the line before we can slide this carb out any further. And that's it. We should be free. Not quite yet. Got the fuel solenoid. So I think before we dig in on this, we need to get the linkage for the governor disconnected and these lines off. So we'll set that aside. This is the overflow. And the drain. And now it's pretty much like a normal carb. So we need to get the fuel solenoid off. There's just two GIS screws right there holding it on. And sometimes those can strip out, but that one came right out. Huh. This one starting to strip out. So let's use some vice grips on that one. All right, that one's turning now. So probably a better approach is just to crack those free initially with the vice grips before trying to spin them out. But they are out. And yeah, that solenoid, it's locked up. So that is an issue for sure. Also, you can tell from all the junk that's on the tip, we're going to find more of that inside the carburetor. So we'll get the bowl off, just a 14 millimeter nut. Here we go. And actually, not too bad. Not a lot of buildup. This is not the main jet, but this is what the solenoid plugs. And that is the main pickup for the fuel. So once that solenoid deploys, no fuel can get to the main jet. Yeah, not terrible. I mean, there is a bunch of junk in there, some varnish, a little bit of bad smelling fuel, but the bowl itself should clean up real nice. And needle, not stuck. Pin comes right out. Yeah, things actually look pretty good in here. Let's see if that main jet will come out in the emulsion tube. Yeah, it's turning. All right, main jet not plugged. And the emulsion tube, it's moving, I think. Yeah, it's kind of gummed up in there, so I'm going to use an Allen wrench of the right size to get in there and just persuade it to come out. There it is. And yeah, a little bit of varnish. You know, potentially some of those holes could be clogged up. And the last thing we have here, actually two things. We do have an adjustable needle here on the pilot, which can be removed. So let's turn that in, see where it's at. That's 1, 2, just over 2 turns. And lastly, we have the pilot jet. So we have to remove this idle set first. This machine actually does idle, but given that the generator is not making power, I'm not sure it's actually going to function. And the other thing that may not function is the cooling fan for the radiator, so we can't run it for too long. That's it. Carbs fully apart. Pilot, hard to tell if it's clogged. And no, if it was clogged, it was just barely. So yeah, this carb's in pretty good shape. You know, it is a little dirty. So we'll soak it for about 10 minutes, bolt it back on, and go for the first start. And we'll try to free this up. You know, like I said, it's not going to get power. It's probably not going to work anyway. But the position on this is normally open, so it's not going to block the flow of fuel, assuming it's in the down position, which it should be. No, that is, oh, just broke free. All right, good. So I'm going to hold that kind of in the up position. We'll get that last bit of varnish off. And this will be good for future use. Good enough. All right, carb is out of the ultrasonic, cleaned up really nice. The bowl, definitely better, but there is still a little bit of staining down there. So that, isn't ideal, but it shouldn't affect the run capability of the carb. So we'll get it back together, starting with the emulsion tube and the main jet. And next we'll do the needle and the float. Like that. And the bowl, we want to face the drain forward. And the last thing here on the bottom is the fuel solenoid. So this one, the wire was facing toward the right when looking at the carburetor like that. So we want to get this on in this orientation. Technically, you can install it the other way, but then the wire is going to go the wrong way. All right, and we can get the needle back in. So we're going to lightly bottom that out and then back it out just over 2 turns. That's 1, 2, and a bit. Then we have the pilot jet. Spacer on top. And the idle set. So this generator, it does idle, or at least it did. Given that there's no power, I'm not sure if it will. So we'll test that. If it does idle, we'll have to set the idle speed, but for now, we're just going to leave it backed out pretty far. So if the idle does come on, you know, likely it's going to stall the engine out until we make that adjustment. But at this point, carb is clean and ready to go. So let's get it reinstalled. All right, so we're going to get the carb back on the machine. Got the governor rod reattached to the carburetor. So this has to go on first. Otherwise, you're not going to be able to get this arm on after the fact. And then we have to reattach the arm to the governor shaft. So there is a flat right here. So you can only hook this up the right way. And assuming it was calibrated right to begin with, then it should still be good after the fact. But I'm going to get the governor spring back on first. And the tension here, it's going to be fighting us. We could loosen off the tension. That would help. But then we'd have to reset the speed, which isn't a big deal. We might end up having to do that, depending on how this goes. There we go. Just a little bit more. Like that. So now we are connected. Throttle plate moves without issue. So we can get the lines connected, starting with this vacuum port, which I think is actually what controls the idle on this. Yeah, there is a vacuum servo. You can just maybe see it up here. And it has this arm that when it actuates, it's going to bump that throttle plate. So that might actually work since it runs on vacuum, but I guess the auto idle part of it, you know, I'm thinking that is likely a circuit that has to trigger an air valve somewhere. Anyway, we can get the overflow connected as well as the drain tube. And we're going to leave this one off. We're going to feed the carburetor with an external tank. And next we need to get the boot on. Not that it's going to do us a whole lot of good, but we do have the remote choke wire, which would be useful. That's weird. So we got the fuel solenoid plugged back in. Just got the breather. Add a bit of fuel. And I think we'll be ready. And we do have some of the covers for this machine. So I'm thinking we get that and the heat shield installed before these parts get lost. So I think that one would have gone right there. And actually this one doubles to hold that panel that we removed earlier. So let's pull this one back out. And we've also got the grill for this side, so we'll get that installed. Like the other side, the hardware was missing, and actually both grills were bent, so I had to straighten them out. So, you know, besides the cover missing on the stator, we have most of the parts that go to this machine. But we are missing the top trim piece here, and also the handle used to roll this around. So we get the fuel line plugged in, and the line I'm just going to secure up top to the rail. All right, I think we're good. The needle mostly closed. It is still dropping a tiny bit. So it's possible it might flood over, or, you know, maybe when the bowl gets just a little more fuel in it, it might seal. Should be good enough to test with. So the needle, it did fully shut off. So we're good from that point of view. But I just happened to look under the machine and noticed this big, huge bolt sticking out with, it looks like, Teflon tape on it. That is actually the drain for the cooling system. So that bolt for sure, not factory. And hopefully they didn't mix threads. So that is a problem, but not today's problem. So let's crank the engine and see what we get. All right, I'm going to keep the main circuit breaker off. Shouldn't matter anyway. We don't have a voltage regulator. All the wires are disconnected, so there's no way it's going to make any power, at least on the high voltage side of things. Although I am kind of curious about the battery, if it's going to charge, and potentially if the cooling fan's going to work. So we will put probably a voltmeter on that battery once running. But let's get it running first. Contact. You gotta love Honda. So it's really a shame that we need a new stator and can't get one, because the engine, it runs perfect. I mean, this thing instantly fired up, could turn the choke off right away, and it ran perfect. So the engine is definitely 100%. The electrical, yeah, not so much. I did try the auto idle, had no response, and I'm kind of curious now about the battery. I did just put the multimeter on it, and it's actually at 13.47 volts, which is pretty high. So potentially the engine has a charging system for the battery, and maybe it was overcharging. So let's get it restarted real quick and see what the voltage does on the battery. Yeah, I've let this sit for a while. The voltage came down a little bit to 12.99. So yeah, potentially it was charging. Although when cleaning the carb, I did have a battery charger on the battery. So that voltage might just be a result from that. So let's get the engine started, see if the voltage climbs above 12.99 volts. So yeah, I don't think the battery was charging. I mean, the voltage was climbing, but I think it was just recovering, after cranking the engine. So no surprise, the 12-volt charging system for the battery does not work. The auto throttle does not work, and likely the cooling fan does not work. And of course, the main outputs do not work. So this machine really just needs a new stator, but I cannot locate one. So if you happen to have one and you're willing to part with it for a reasonable price, please let me know. Or if you know where I can get one, let me know, because this machine deserves to be repaired. So I hope this video helps someone. Thanks for watching.